Hello guys and welcome to this new video on the OpenGL series. Hope you guys are doing good. Now in the previous video we created our first window using GLFW. Now we want to move forward and draw our first triangle on the screen. So if you guys are watching this video for the first time, just make sure you go and check the previous video first. And also one thing I want to mention is my plan is to upload a video each week about OpenGL. I want to teach you first how to use OpenGL to achieve some basic tasks, and then the next part of this will be to create a game engine using OpenGL. So if you guys don't want to miss any of our videos, make sure you hit that subscribe button and also like this video. It means a lot to me. So let's get started. Now the first question I'm going to answer is why a triangle? All courses about OpenGL always start by drawing a triangle. So why? Now the basic reason for that is because your GPUs actually use the triangle to draw all kind of shape, all kind of structure, all kind of things. So that's the reason why we always start with a triangle. But we can still ask ourselves, why did they choose a triangle over a square or a cycle, for example? Let's talk a little bit mathematics right now. Giving 3 points like here in a three-dimensional space, it doesn't matter how you're gonna put this point together in the space right here, you will always get a surface. But the condition is you can put two of these points in the same position, you can get a surface from that. So if you put them in this three-dimensional space right here, you will always get a surface, you will always get a triangle with a surface, so to say. But if you have like 4 points and you're trying to do that, that won't be possible. Now having a surface is really important because you want to be able to know where you want to draw your pixels, or you want to kind of put your texture. That's the reason why we use the triangle for that. So one thing I also want to say is each of these points right here in OpenGL is called a vertex. But I don't want you guys to get this wrong. A vertex has nothing to do with the position. A position can be a vertex. So because a color can be a vertex, just want to make that clear so that you guys don't confuse with that. Now it's really important to talk about the graphic pipeline because this is basically how OpenGL operates on the graphic card. Everything is OpenGL is basically three-dimensional, but the problem is your screen is a two-dimensional space. Now the basic job of the rendering pipeline is then to take your three-dimensional coordinate and then turn them into a two-dimensional coordinate that will then be rendered on the screen. So the third dimension is just a trick, just like an eye trick. You have the feeling that there is a depth, but these are just two-dimensional coordinate drawn on the screen basically. So the rendering pipeline can be then divided in two main parts. The first part will then turn your coordinate, your three-dimensional coordinate to two-dimensional coordinate. The second one will then make sure he put the color on those two-dimensional coordinates to actually have the result on the screen. This is a more detailed view of that graphic pipeline. Some people actually refer to that as the rendering pipeline, so don't get confused with that. And you can see right here we have the first part, which is the one I said was kind of taking our vertex data and turn that into coordinate basically. And the second one will simply go out and put some colors on that and handle things like blending or transparency. Now we're gonna be talking more about each of these as we use them. In this video right here, to actually draw our triangle, we're gonna be creating a vertex shader and a fragment shader. The shader is just a program written that run on the GPU. So you will write a program using the OpenGL custom language GLSL. So it is OpenGL shader language, and you will compile your program and bind it on your GPU so that he can use it to draw things on the screen. So we have different kinds of shader. We have the vertex shader and the fragment shaders. We're gonna be creating a vertex and a fragment shader in this video because the vertex and the fragment shader are both required for you to actually draw anything on the screen in OpenGL. The geometry shader and the tessellation shader are not required. You can get some default from OpenGL that are just right away from the memory, and you don't have to write this before drawing your first triangle. Now these boxes right here that are gray are those where we can write shader for. Those are abstractions, so we can't actually do anything on that. So we're going to be talking a little bit more about each as we move forward from that. Before we then move in the code, I want to show a last thing. This is what we want to achieve. You can see this is our triangle right here, and this is our coordinate, our screen. And if you remember, this is the coordinate system. So the X is going positive on right and the Y is going positive on top. So if you want to draw a triangle, you always make sure your vertex or your vertices are always within the range of -1 and 1. So you have one vertex here, which is 0 on the x-axis and 0.5 on the y-axis. And we have this one -0.5 on the x and -0.5 on the y-axis. And you can see this is the triangle we want to draw. And so we know now that we have 3 vertices. We have this one, and this one. That's what we're actually going to be using to draw our triangle. So now let's get into coding. This is where we left last time. We just created the window, as I said in the beginning of the video. And now we want to draw our triangle on that. But before we do that, I want to mention some couple of things that I forgot to tell you, because I think that's really important. Now the first thing I want to talk about is the glf terminate. So you want to make sure you call this function, because glfw actually allocate memory in the background for many things that we don't know yet because we don't care about. So we want to make sure you deallocate all that memory by calling glf terminate. So that's one. Now the second thing is this one right here. Now one thing I want you to know is OpenGL actually stores each pixel of your screen in a buffer, which is referenced to by this GL color buffer bit. So each pixel of your window is stored in a specific memory in your graphic card. And now you want each loop cycle to actually clean the screen, to set the color, to clean the screen before drawing anything new on the screen. So this function that we call right here will then define the color that we want to set on the screen, the background color, so to say. And then we can simply go here and fill the memory with this color right here. And as you can see, colors in OpenGL are given in RGB format, and the value are between 0 and 1. 1 being equal to the 255 that you probably know, and 0 being always 0 as always. So this was also important for me to point out. And also I didn't show you guys how to actually know the version of OpenGL you were using. I'm sorry for that. So to actually know the version you're using, you can simply go out and get the string and put this enum right here, and OpenGL will, and you will get the version of OpenGL you're using, as you can see right here on in my case. So that's it for everything we forgot to do. Now let us move forward and start drawing our triangle. Now the first thing we want to do is somehow to define our vertices and actually send them to the GPU. So this is how we're going to do that. I just paste this. I'm going to explain, because my focus is more on explaining. If I write this, that doesn't help that much if I start writing. We can see right here we define our vertices. You see we have each vertex right here on the X, Y, and Z axis. You can see the third component is always 0 because we're not dealing with depth yet. We're going to be doing that later. Now if you remember from the first video, I told you how you could create an object in OpenGL. So we basically have a function to generate the object, and we always get an ID that helps us actually refer to that object whenever we want to use that. So this is basically what we're actually going to do here. This data right here is running on our program. This program is running on the CPU, but we actually want this data to be on the GPU so that OpenGL can use it to draw our triangle on the screen. So we need a way to actually send this to the GPU. And to do that, we first of all need to allocate memory on the GPU. And to actually allocate memory on the GPU, we can call GL generate buffer. This will go out and allocate memory on the GPU. Now we don't know the size of that memory or anything like that. It just kind of reserve a place and kind of make sure we have a buffer there that we can use. Now this function right here takes 2 parameters. The first parameter is the number of buffer we want to generate. You can see it's generate buffers with S, so we can generate multiple buffers. And the second argument right here is going to be the handle of that buffer. So this function will write the value, the index of that buffer inside of this value. So if you want to create multiple indexes, we can simply put how many we want to create right here, and then we can pass an array of unsigned integers to actually store each index. So that's basically what we do in this case. We need to tell OpenGL that right now we're working on this buffer right here, and for that we call GL bind buffer. We set the type of the buffer, which is an array buffer that we created up here, and we pass the index of that array buffer right here. Now what we want to do is to pass our vertices. We want to pass our vertices to the GPU so that he can use that later. So the first thing, the type of the buffer we're using right here to pass the data. So the first parameter we pass is the type, and we need to pass the size. So OpenGL need to know how many memory it should actually allocate right now to get our data, and now we can pass our data. And we have this fourth parameter, which is the usage. Now that last parameter actually tells OpenGL how he's going to be handling this data. So you can see the value that we had there was GL static draw. This actually means these vertices are not going to be changing all the time. But this is actually important because if I have an object, an animated object that has, you know, vertex buffer, vertices, then I'm probably going to be using the dynamic, because the dynamic actually tells OpenGL that the object is likely to change. If my data are going to be changing each frame, every time I render something has changed, then I'm going to be using the stream draw. This is something for animations, because your animation is still going on, and you know that's really important. It's really important to know which one to use, because using, for example, a stream on a static object doesn't really make sense, because OpenGL will give himself a lot of work to actually make sure he always update this data in the GPU, but nothing would have changed. So this will actually decrease the performance of your program. So make sure you use this properly. Don't just put because you can put. And also you can put a static on an object that is likely to change. Now we want to actually specify how this data is going to be used on the GPU. This is where we actually start sending data to the shader. We're going to be implementing our shader in a couple of seconds. And in OpenGL, to actually send the data to the shader, we have the so-called vertex attribute. We also have things like uniforms, but we're going to be talking about uniforms later. And you can see right here, the first parameter here is the index. I'm going to be explaining that as I show you the code of our shader, so you guys understand why it is 0 right here. So this is the first attribute is going to be 0. This is the index of our first attribute in our shader. But the second argument is now the size. How many components does a vertex have? So you can see right here it has 3. So that's why we put the 3 here. The type, so it's just float. Now this is to normalize. We're going to be talking about normalization later. For now, just put false. We don't want to normalize them. Now the fourth or the fifth component right here is the stride. So you see our vertices, we have 3 vertices. We have 1, 2, and 3, and each has an x, y, and z value. Now the stride is how many bytes we have to move to get to the next vertex. So you can see right here, for each vertex we need to move 1, 2, 3, you know, float. Now a float can have like 4 bytes, in our case 4 bytes. So we're going to be moving 12 bytes to the next vertex. That's the stride. So our stride right here is 12. The float type can differ from system, from system to system. So you want to make sure you use the right value for float. That's why we simply call size of. This will always be true no matter the system you're working on. That's the reason. And so the last element right here will be the pointer to the first element, which is just the 0 element. Now in some case you can remove this void right here, it will work, and in some case it doesn't. I just don't know when it doesn't and when it does. So just to make sure it always works, just put this GL void, and you will always have it right. So this will simply be the pointer to the first element of this array right here, simply. And we also want to go out and enable the attribute that we just set it. Now remember that OpenGL is a state machine. We've bounded this buffer right here. We're actually working on this because it is bounded. We're doing all of this on this right here because we told OpenGL that bind this vertex buffer. I'm going to be setting some attribute on that. So they are still bounded yet. So that's why everything we're doing right here is on this vertex buffer right here. Just want you to keep that in mind, because I could have enabled this even before this. It doesn't matter. I just set that and I can do this. So it doesn't matter how you put it. But since I want to work on this buffer right here, I need to bind it first. So keep in mind that OpenGL is a state machine. So the last thing I have to do is to actually unbind my buffer. And in OpenGL, unbinding a buffer or an object in general is just binding it to zero, to the zero buffer, so to say. Then we have it done. And it's always recommended to unbind your object when you're not using them. This makes sure that you don't do crazy things while trying to change anything around that. Now you can see we have our data, and we also lay out how this is going to be sent to the GPU. We said we have 3, each vertex has 3 values, so the GPU will be reading 1, 2, 3. So we already have everything in place, but now we need the shaders that are like the API between the GPU and our program, where we'll be able to send the data and we will use that to draw our triangle. And that's the next topic of this video. It's going to be using string to define our code, because we will have a specific video about shader where we'll create our shader class that will load and compile all kinds of shaders. So that's something we're going to be doing in the future, but for now we're just going to be coding this in line. So I won't write the code right now because that will give us a lot of work, because writing strings is really terrifying. So I just paste the code right here, as you can see. Now I hope you guys can see you have the version of the core profile you're using right here. I put 3.3 3.3 because you're probably using the OpenGL 3.3 version, so I just put this. But in my case, because I put any profile right here, this gives me the right to actually write this. Each shader in OpenGL has a main function, as you can see here. Now one thing which is really important to me here to mention is this layout here. Now if you remember here, we set this GL vertex attribute pointer. You can see right here the vertex attribute pointer. This is actually what we're defining here, and you can see location is 0, which is exactly the index that we have here. So every time this data is going to be sent to the GPU or to the shader, it's going to be on this guy right here because he's at this location right here. So that's basically how we do it. And we're going to be doing also a specific video about GLSL, explain all the types, how to write code with GLSL. So you can see right here we have a basic type of vec3, which is a vector of 3 components. We call it position, and we simply go out and return this GL position, which is a OpenGL, which is specific to this language right here. This is not a variable we've created. OpenGL actually knows this guy here. So we simply send this variable to the fragment shader. So this guy will create, for each position, he will create a vector of 4 and send it to the fragment shader. Now we could have sent a vector of 3. Later we're going to be understanding why we're using vector 4 instead of 3, because vector 4 actually make the job easy for the computer to make calculation and things like that. And also the color has 4, the RGB and A for the transparency. We could have simply sent the position as a color to this. We will use that to draw, but you could have sent, as I said, a vec3. That's not a point. So this is the vertex shader where we send our attribute pointer, and he will then calculate the position depending on all kind of operation you might want to do. You could do them here. We're going to be talking about transformation later and projection. All of that is going to be done here and then sent to the fragment shader. That will then turn this into a 2-dimensional colored pixel basically. So, and he sends this to the GPU, which is a color basically. So this is our code for our shader. Now we need to kind of load this and compile this so that we can use this. So we want to do that right now. So we want to do it just right after we ask the version of our OpenGL, because normally if you're building a game engine, you will load your shaders first before you start doing anything. That's why I'm just writing in there, but we could have done it after this. Doesn't matter anyway. So I just want to write a small comment here, shaders. So I just paste the code to make things faster, and I'll try to explain. You can see right here, the first thing we do is to create a shader, and we specify which type of shader we're creating. This is a vertex shader. And now we get the source code. You remember we have our source code up here normally. So we give the handle. You remember it's the same thing. So we get the handle, we simply pass the handle of the shader that we created, and we pass it here. And the second argument is only one shader, so we just put one there, so it doesn't matter. And now we simply give the address of our source code. The last argument was about the length. It doesn't matter. We could also pass the length of this guy here, but this will be done internally, so we don't need to put that. We can simply call GL compile shader and put it here. Now, one thing which is really important while writing shaders is to always make sure you keep an eye on the compilation process and see if everything went properly, if we didn't have any errors. That's why we need like a control system to actually see what happened during the compilation. And to do that, we kind of want to create this variable success right here, which will store the state of the compilation. So, and we have this array right here, which is going to store the message, the error message of our shader. If anything went wrong, it will store this in this array right here. So we go out and say GL get inventory, get shader inventory, and we specify the handle of that shader and which inventory we want to get to be the compiled status. We also have the link status, so that's also important. So you can see we want to see for the compilation if something was wrong, and this will write the value that the compiler returned. So if the compilation was correct, it will, and if success is different from 0, then something was wrong. And then we want to just kind of show the message that was written in our info log. That's why we go and get the message right here, put it in our table, and then show it here. That's what we do for the vertex shader. We want to do the same thing for the fragment shader. So it's the same process. The only thing that changes, we simply go and say GL fragment shader, the one we're creating, and everywhere you have vertex shader, you just replace it. So don't worry, we're gonna be wrapping all of this in a class that we can simply call and say compile or do something like this, and this will be done easily. But for the sake of this video, we're gonna be writing some crazy code. I want to show you how this can actually work. So if I go on and add something wrong here, if I remove this tree right here and I try to compile, we'll see we'll get an error message. So you see, error shader vertex compilation failed, and you see they actually give you what was wrong. You see they say vec because we didn't put the tree there. You see how this can be good, and I just know, okay, I have to go here and put my value tree, and if I compile it now, everything's gonna be just fine, so we don't get any error message. That's really nice. Now let us link our program so that we can use it to draw things on the screen. Paste it. Now as you can see, we create a program right here because both the vertex and the fragment shader are going to be linked together in a program that we're going to use. You remember I said to actually draw something in OpenGL, you need to have at least a vertex and a fragment shader, and both of those shaders are going to be linked together in a program. And every time we call GL use program and pass the ID of that program, we will use those shaders, so to say. So we have shader program, we create a program, and we want to attach our shaders. We attach the vertex and we attach the fragment shader. And now we call the link function, which is going to link both together. And now we also want to make sure the linked was successful, because if you don't make this, you will never know what was wrong, because anything might happen. And we do the same process to get this time the inventory, but we want to get the link status. And we use our same variable info log in success, and we simply send the error message out. So now we basically have our shader in place, and we can now really move and draw our triangle on the screen. But before we do that, just make sure you also call the delete buffer at the end of your program, because you always want to free the memory. Now to actually draw our triangle, all we need is to go, after we've cleared the screen right here, we want to draw our triangle. And to do that, the first thing is we want to use our program, our shader our program that we created from our shaders, from the vertex and the shader. And we want to bind our buffer. You remember we're using this array buffer right here. We want to bind that, actually use the data inside of that buffer. So when I say GL bind buffer and I bind my VVO, I'll simply go out and draw with draw arrays. You can see I give the amount of element I want to draw. So the first element here is GL triangle. The second one is, that's actually the index of the first element and the count, how many elements you want to draw. Now this first element right here, you have GL point. You can actually decide, instead of drawing a triangle filled with a surface filled with pixel, you can draw just 3 points on the screen, or you can draw GL line strips. So, and you got your triangle on the screen with a nice red or whatever color you have. Now this color right here comes from the fragment shader up here. So this is the color we've set here. You see the fragment shader simply has a main that returns a vect4. You can see out vect4. This is output. That means the next step will simply take the value that come out of this and use that to draw. And OpenGL actually knows that this guy here returns the color. So you will take that and actually rasterize each pixel with this color right here. So, and yeah, that's basically why you get that triangle. So if I go out and make something like one here, let me stop this and run again. You will see you will have a triangle with a different color. See, now it's yellow. So that is a lot, I know, for one video, and it's not really easy to draw something like this in OpenGL, but when you get this for the first time, it's going to be easy to do other things, because OpenGL actually has some way to automate this so that you can draw multiple objects. So that's it for this video. In the next video, we're going to be adding some couple of things on this to actually play around with that, like changing the colors, animating the colors, or adding colors in each corner of the triangle. So I think this video is getting too long and I don't want it to be too long, so we're gonna be stopping right now. So thank you guys for watching. Please subscribe if you haven't, like this video and share. And if you guys have any question, or if I didn't explain anything well, I'm always open for critique. And yeah, I just try my best, and if that helps someone out there, then I'm happy to know it does. So you guys have a nice day, or a good night, whatever. So ciao.